Welcome to Programming Rainbow. In this video, we will continue on the series to the Beginner's Guide to SDL2 in Haskell. So if you would like to follow along with this video, you can go to github.com, Programming Rainbow, Beginner's Guide to SDL2 in Haskell. You can clone that repository, move inside the directory, and you'll be where we are. So let me just show you when you do clone it and move inside of it, what you get. So you're going to have this entire set of directories here. These are all the source code for all the different videos. We will be working inside of app. This is where the actual source code that you're going to build is, but these video 1, 2 to 8, and even the old ones are just other versions of this code right here. So for video 1, which was the last video, is the video that is currently in this app folder right now. If you just cloned it though, you probably have video 8 code in there. So you'll need to copy the code from video 1 in there, and you'll be right where we are starting with right now in this video. So let's look at this code. So this code right here, what we've done is all the boilerplate. It was a very long video. Sorry for that, but there was no real way around it. We did open window last time, and it stayed open for 5 seconds and then closed. So let's just show that off. Okay, I can't close this window now. It's going to stay open. And it's going to close itself. If I try to close it, let's say if you're on Windows or something else, I'm not really sure what happens, but it'll probably say like your application is not responding or something like that because we are not actually processing close events yet, but it will close on its own after 5 seconds. That's what this delay 5000 right here is, 5 seconds. Okay, so in this video, we are going to make it where we can close it. We're going to set up a proper game loop where instead of waiting 5 seconds, it's going to wait 1/60th of a second approximately, and it's going to loop continuously until we tell it to close. And we are going to set up the actual normal way to close a window, and we'll use the escape key as well to close the windows. That's what we're doing in this video. I'd like to show if you need to set up your NeoVim. I do have a prior video setting up the NeoVim that is also on github.com, Programming Rainbow, and this one is NVChad 2.5. So if you want to set up your NeoVim, that's where that is. That actually has all the different stuff. Okay. So let's look at what we need to get started with making a game loop and then shutting it down. So if I were to just make it loop right now, I would have no way to shut it down. So what I really need to do is get the events from SDL and find out if the event is a close request, something requesting that I shut the program down, or if it's a keyboard that I'm interested in. I can ignore all other events. So this is kind of a mock-up in the, if we're at package.haskell.org, packages, and this is under the SDL2, the current SDL2 package. And if I just click on SDL2 here, so if you've done any of my other videos with SDL2, this is going to be just the Haskell version of it. So what we do need to do is get the events, go through all the events and process them, find out, what it is. So it is a little bit confusing. I kind of think about this, the way this is kind of like if you've ever programmed C and you have to deal with creating a pointer in C and also dereferencing the pointer in C, how the syntax is quite confusing because it uses the same symbol but in different ways to mean the opposite thing. It to create a pointer and also to dereference a pointer is the same symbol. So it's a little bit like that here. So the syntax might look a little confusing if you're not a seasoned Haskell programmer. I'm not a seasoned Haskell programmer, so it is a little bit confusing for me. So I'll just try to walk through this step by step. I'm just going to show off what I've already kind of come up with and use that as a reference. I'm going to open up my second video here. Oh, I know what I was doing. I was modifying this. Yeah. Okay. We're just using this as a reference anyway. So what I really need to do is make a function that handles events. This is going to be a recursive function. And then I'm going to turn the game loop where it runs recursively as well. So we don't want to set the game loop recursively just yet because we would have no way to shut it down. So we do need this. We do need to handle events so that we can shut it down with events. So I'm not going to use it the same way as this. There are some changes to this I'm going to make, but basically we do want events, and then we also are still in the state t game state IO context. So we're just going to be dealing with events. This is going to be recursive, so let's just start writing it out. So I'll put it right above the game loop. And I think I just called it handle events or something like that. Yeah, handle events. Okay, so we are going to have some events. Let's see if it's just SDL event. Yeah, it's just SDL event. It's just a list of SDL event. And if we go to the website here, so pollEvents is going to give us this list of SDL events. But remember, we qualified SDL, so everything you see here on this page, you do need to put an SDL dot in front of it. So when this says event, for us, it's going to be SDL.event. So this is the events that we're dealing with right here. The list of SDL event, and then we're going back into the state transformer with game state IO. This is recursive, so we need to deal with the base case. So that's going to be our base case. When the list is empty, just return. Okay. I know there's another item there. That's because I was actually passing in game data, but I don't need to pass in game data for this at all. So I removed it, but I didn't remove it all. So this is actually broken code right now. Not on the GitHub, just on my computer. So now we also want to split up the events. I'm not going to name it this way. I don't like this name either. So we need one of the events to deal with, and we are going to then, at the end of it, recursively call with the rest of the events. So we're going to use the colon to get the head of the event. If this is all of our events, we're going to have the first event and then the rest of the events. So I need one event, then the rest of the events. And later on, it's going to call, itself on the rest of the event. Down here, it's just going to call itself again with the tail of the event. Okay, so what we want to do here, we're going to take the event and get the payload of the event. So I think it's on the page here. This is going to take one of the events. This is a function applied to the event. It's going to give us a type payload, event payload. Yeah. So this is going to get a little bit confusing, but we're going to match on that with the keyboard event constructor, which we're going to bind the output of that, which is going to be of type keyboard event data. And then that can be processed all down through here. So first we want the payload. We want to run a case on the payload itself. So that's the first thing we're going to do. So again, for us, it's going to be SDL payload event. And ours isn't going to look like this, though. They're doing it slightly differently than I did it. But we still do need to get the event payload. Payload, and this is on just one of the events. Okay, now that we have that, we can match on the payload. So we have two different constructors that we can match on that I'm interested in for this project. One of them is a keyboard event, and the other one is a quit event. So let's look at that real quick. They have this keyboard event right here. So this is a constructor. It's going to bind. Sorry, let me click on it again. This type here, keyboard event data, is what is going to be bound to this keyboard event right here. So this keyboard event right here is a constructor that constructs a event payload. We're kind of using it as a match and to actually bind the keyboard event data to keyboard event. So this is the part I find confusing. The type that is returned from this is a SDL event payload with a capital E. That's the type. The type returned from this constructor is the same type, but that's not the type of this. It's being bound to this. So it's like this is being used to match. I still find this confusing, but this is being used to match. So it's saying if it does match, bind the keyboard event data to this name keyboard event. Somebody may be able to explain it much better than me. It's like being used as a constructor. So the actual type we're getting in this keyboard event is keyboard event data, SDL.keyboardEvent data. That's the actual type of this that's being bound to this. So we can process this more and deal with that more. The other thing that we are going to want to do is not the keyboard event, but the quit event. And we don't need to bind, anything to that. We're just going to match on it. So the way I've done it here is I'm actually matching on keyboard event, binding the output to this keyboard event right here. I'm also matching on SDL.quit event. And I don't need to bind anything on that one. So these are my two cases that I'm matching on. Hopefully that made sense. I know it's a bit confusing. Like I said, for me, this one is just the way it reads and the way you think about it is slightly confusing because it's like a deconstructor. So this one, SDL keyboard event. Yeah, sorry. It's not a, this one's not a function. It's a constructor or a type. Keyboard event. And then we got keyboard event. And then we're just using a guard on that. The other one is going to be the SDL event clean. So I'm using a guard on this because I'm only interested in a specific key down event is what I'm interested in. So I'm not sure if they've done the same thing here. So now that they have this keyboard event, which is of type SDL keyboard event data, they can process this. So this function right here applied to this data is going to return keyboard motion state or something, input motion. It's going to turn input motion, and we are checking to see if that is SDL.Pressed. So that's why we needed to bind it to keyboard event data so we can keep using it, processing it later on. So this keyboard event motion type applied to keyboard event, and then we can check the value of that against SDL.Pressed. That's how they're doing it. I may be doing it slightly differently because they're also anding it with this. I think I've written it slightly differently. So I've used a guard here, and I'm doing the same keyboard event motion. I'm applying it to keyboard event, and I'm doing the exact same here. But I'm just saying if that is, then do this other case on it. Because what I'm going to do is I'm going to be able to check different keyboard events later on. So we're only checking one right now, but later on I want to be able to add more in here. So I do want a further case on which key it is, where I think they're just checking one key or something like that. So, and this is the same thing here. This keyboard event Keysym applied to keyboard event is going to give us a SDL.Keysym. This this KeysymKeycode applied to that is going to give us the specific key. And we're matching on that. And if it matches on the KeycodeEscape, we are exiting. And for everything else, we're just returning. That's if it's a keyboard event. If it's a quit event, we are doing the same thing. We're doing our exit clean. We're doing our exit clean here. For any other on this match, we're also returning. And this is just going to keep recursively running until the list is empty. For me, I was like looking this up over and over again because I know exactly how this works in SDL, but the way it works with the functions and the constructors was a little bit confusing. So I just wanted to say, this right here is returning a payload. This is matching on that and binding the keyboard data to this name keyboard event. And then we can use that to apply functions to it to get different bits of data out that we want, so that we can see if it was a keyboard pressed event that happened, or we can see which actual key was pressed, and then we can do our action that we want, an exit clean or a return. And the same for here. Okay, so I hope that's clear as mud. I wish I could explain it a little bit better, but hopefully that made a little bit of sense. But again, if we look through this one here, we have the same thing going on. We have our payload, and then we are matching on the payload, and we are binding the keyboard data to this. Here we are applying this key motion, the keyboard event key motion, to that keyboard event data. And the result of that, we are checking it against SDL.keyPressed. And there are also logical AND here to do 2 checks, to also apply keyboard event keysym to see what keysym it was, and then apply the key code to that one, to the answer of that to get that, and then check it against SDL.keycode Q. So they're actually checking if you pressed Q. And that's how they're closing. And they're doing it slightly differently here, but those same functions and constructors and matching is happening here, but it's in a slightly different way. First thing we got is the keyboard key motions applied to our key event, checking to see if it's just a key press. Is it keyboard key event key motion? There we go. And this is applied to keyboard event. And then we are seeing if this is an SDL. So if it is pressed, I want to find out which key it is. So I need to drill down to the keysym and the key code. So the first thing is getting the keysym right here. So this is keyboard key event keysym applied to it, and then we are doing the keysym to key code. So keyboard event keysym. Keysym applied to keyboard event. And we need to apply the other one, SDL, the keysym keycode. I think that's right. Yeah. So we're doing a case on this, so we can have multiple different keys that we're checking later. Okay, so the case that we're interested in, I'm going to use you can use the Q key too. You can mess around, but I'm using the escape key for this. So I'm matching on this SDL.KeycodeEscape. So you can just change the escape part to whatever other key that you want to do. Escape. And this is going to be exit clean. Exit clean. And then we also need to match on anything else. And we have the other case besides the keyboard is the SDL.quit. And this is going to be the same, exit clean. And anything else that doesn't match either of these, we also need to just return. Let's see how far I've gotten here. So I've gotten this, yes, yes. And we just need to recursively call itself then. So this is going to be handle events. We want to send in the rest of the event. So we separated event from events. Now we want to send in the rest. So that was the complicated part of this video. Implementing this now is going to be very simple. What we have going on here is we're running this one once through, it's waiting 5 seconds, and then it's exiting. Now we can simply just call it self. So we do need to pass the game data back in. I'm just going to say game loop, game data. Okay, this is going to make it loop infinitely. And the other problem is I'm having it wait 5 seconds. So my game loop is going to run at, one loop every 5 seconds. This is way too slow. So the simple, dirty way to approximate 60 FPS is just to tell it to wait for 16 milliseconds. It's not exact and it's not perfect, but for this simple project, it's just fine. You can use other methods to calculate and all that, but I'm just going to use 16 just because it's very simple and it's going to approximate what I want. So it's going to be good enough is what I'm saying right now. If you're building a real game, you probably won't be doing this. I mean, like a larger game. If you're just doing simple toy games, this is going to be fine. Okay, so we do have one more problem is we actually need to use this function. So they used, they're getting the, the pollEvents here. So they're polling the events. They're getting this list of events called events. We're just going to use the bind operator to bind them together. So I'm going to use pollEvents, and I'm going to bind that right here to this function right here. So since I could put it in 2 steps, but you don't need to. So I could do it, let's see, I'll show it both ways. So I could do this right here, what they're doing. And we need to prefix this with SDL. Okay, I could do this, and then I could go handle events and put events. That should work just fine. Let's give it a try. I do have 16 milliseconds here. I am calling this function that I'm inside of with the game data that was already passed in, so this should run recursively. And the handle events should run recursively until the list is exhausted. And that's why we have the first one up here being our base case. So I'm going to cross my fingers and hope this runs. So I'm going to tell it to close with the standard way that I would tell in my tiling window managers to close a window. Okay, that worked, and I'm getting all clean. Now I'm going to try the escape key. I'm going to press escape now, and that worked too. Okay, and let's just change this now to bind. So what I'm going to do is just do this, and that should work the exact same. That's just taking the output of this and putting it as the input of this. Okay, so it's running. I'll let it wait 5 seconds. It's not closing down. Okay, I'm going to tell it to close now, and let's run it again, and I press escape and it closes. Okay. And we could try this by putting something else in there real quick, just to see that we can add other. So this is expandable easily. I can just go SDL.KeycodeEscape, say space. And let's say, I think I need to lift this because of the context that I'm in here. But I'm going to do a put Sterling, and we can just say space. That should work. Okay, so now when I press a space bar, it should just print space. And we'll see that down here. Okay, I'm going to press space. Yep, and then close it. So you see how that's very, now we can easily expand it. I'm not sure exactly how you would expand the version that they had. It was slightly different than mine. Going through it again, this is just a recursive, we're just taking a list of of SDL events, and we are just trying to exhaust that list by separating them out to event and events, and recursively we're calling it on events on the tail of the list. We are using this, we're applying this function to the events to get the payload. The SDL.Event_Payload is the type of this. Here we are using this pattern matching / constructor, deconstructor, whatever you want to call it, to check if it's an SDL.keyboardEvent and bind that event to here, which will give us an SDL.keyboardEvent data. That's the type that you get out of this. I'm using a guard here to see if this is true right here. If applying this KeyboardEventKeyMotion to the SDL.keyboardEvent data, when I apply that to KeyboardEvent, that is going to tell me if this is an SDL.Pressed or not. That I'm getting out a different type from that. So if this is true, we're going to further process. And now I have another case that I'm running here on the actual key that was pressed. Okay. So we're still working with this same keyboard event. This is of type SDL.keyboardEvent data. We're applying this KeyboardEventKeysym to it to get the keysym out. And then we're applying the key code to that to get the key code out. And that's what we're matching on. So we have the SDL.KeycodeEscape, and that's just running our function to shut down. And since this is in the state T monad, our shutdown already has access to the list of actions that it needs to do to shut itself down, So that's why we're still in this context. And for all other cases, we're just returning. And for the quit event, we're quitting. If it's neither of these, all other cases, we're returning. And this is just recursive. So we've just changed here. The only thing that we've done here is to bind the output of this to this. So this is getting our list of SDL events. And this is processing those recursively up here. So we've added that one line. And we did change this. If you forget to change this, you'll hit a key and then you'll wait 5 seconds to see what happened, because your loop is running once every 5 seconds. So you'll need to change that 5,000 down to 16, because that represents 16 milliseconds, which is roughly 60 times a second that the game loop will run. And this game loop now is recursively calling itself. So we didn't need to change anything else. That should be everything. And again, you can look at the Haskell.org page. You can click on these links and read through it. I tried to explain it. I hope I did, but if anybody wants to clarify anything I said, they could put it in the comments in the video. Or if you have any questions, just ask. Thanks for watching, and I hope you enjoyed that. Goodbye. Have a nice day.